IPv6 addresses are 128 bits in length and written as a string of hexadecimal values. IPv6 addresses are not case sensitive and can be written in either lowercase or uppercase. Every 4 bits is represented by a single hexadecimal digit for a total of 32 hexadecimal values. For example, the hexadecimal digit 2 is the equivalent in binary to the 4 bits 0010. Every 4 hexadecimal digits is 16 bits, separated by a colon. Each hexadecimal digit is 4 bits, which makes it easy to represent the 128-bit IPv6 address. Each set of 4 hexadecimal segments is sometimes referred to as a hextet. When written with all 32 hexadecimal digits, this is known as the preferred format, which doesn't mean it is always the preferred way to display the address. There are 2 rules which can be used to reduce the number of hexadecimal digits used to represent an IPv6 address. The first rule to help reduce the notation of IPv6 addresses is to omit any leading zeros in any hextet. We are using spaces on each side of the colon to make it easier to read. In our first example, notice that only leading zeros have been omitted. Here is our next example. Once again, you can see that only leading zeros have been omitted, not trailing zeros. And the same holds true for our last example. You will notice that in all 3 examples, only leading zeros were omitted, not trailing zeros. Otherwise, you can see that we wouldn't know which zeros were omitted, leading zeros, trailing zeros, or both. Using this first rule, we know that it is only leading zeros that are omitted. The second rule can be used to further reduce the representation of an IPv6 address. Any single contiguous string of 1 or more 16-bit segments consisting of all zeros can be represented with a double colon. In our first example, we begin by using the first rule to omit leading zeros. Then the second rule is applied, which shows 2 contiguous all-zero hextets. Applying both of these rules gives us the following compressed address. We are using spaces to better demonstrate the differences. Here's what the address would actually look like. Here is our next example. Again, we begin by omitting the leading zeros. Then the second rule is applied, which shows 3 contiguous all-zero hextets. Applying both of these rules gives us the following compressed address. And once again, here's what the address would actually look like. And now for our last example. We begin by omitting leading zeros. Then the second rule is applied, which shows 4 contiguous all-zero hextets. Applying both of these rules gives us the following compressed address. And once again, here's what the address would actually look like. Notice the double colon occurs at the end of our address. The all zeros at the end of an IPv6 address is associated with an IPv6 network address. The double colon can be used only once within an address. Otherwise, there would be more than one possible resulting address. If an address has more than one contiguous string of all 0 hextets, the best practice is to use the double colon on the longest string and apply the omitting leading zeros to the shorter string. If the strings are equal, the first string should use the double colon, but typically it comes down to personal preference.